Hello, I'm going to talk about enhanced audio conference experience submission that's submitted to GitLab. First of all, this is the folder type. Now we can see here there's a test file for the verification purposes, and also dependencies. We can see that because some of the AAMs are directly connected to the third-party applications. For example, they are FFTW, JSON parser, and also Boost library. Now, when we look at the AAM structure, then there are some AAMs, they are only submitted with the source code, but some of the AAMs are submitted in the library forms. They can be seen here in the lib file, and also header files can be seen here. And also this is compiled in debug and release version for Windows. Now when we go through the code, this is a main class CPP. It's an orchestrator between each AI modules. Now, first of all, it just feeds some input to an AIM, then collects outputs of this AIM, and this output is directed for the input of another AIM. Now, in the calling function, we see that there are header files. They are just called with this controller. Now also here we can see that this is the microphone array geometry. It depends on the microphone array that's just plugged into the computer. It can change on the type of the microphone array type. And for this demo, we have used Eigenmic microphone array, and it contains 32 microphones. Then each microphone position is just collected inside this JSON file. And this is the introduction of the code, and here we see that there's a folder, and at this folder we can open the speech files. Now I will open this folder here. This is, for example, we will just open the AC2. Here inside this folder there are 32 speech files, and also there is an audio scene. It's the averaged value of each microphone. Then each microphone recordings are aligned. First of all, we will see that this is the audio scene that will be tried to be separated.
Le fond froid qui traverse le pays d'est en ouest provoque un changement de temps et une baisse sensible des températures. En fin de semaine, l'anticyclone des Açores se déplacera vers l'Espagne, entraînant des perturbations orageuses sur la plupart des régions du sud-ouest.
And also analysis is applied for each block. Then at each block we just collect the elevation and also the azimuth direction of the speech sources. At this time the distance is not regarded, and we cannot calculate the distance for each source. Now at the end we create an audio file, that's the separated audio file for each separated samples. Now we just run the code. Here we see that the analysis just performed for block by block. When I stop here, we see that there is a source 0 and source 1. Their locations are just found by the algorithm. Then for each sampling time is about 42 milliseconds, and the time difference between the analysis is about 17 and 18 milliseconds for the calculation over the CPU from the starting point to the end point. Then when we complete the real-time demo, we obtain the separated files. Then here it's written as separated.wow. Now these are the separated files from these samples. Now we open the separated source one.
In the course of a December tour in Yorkshire, I rode for a long distance in one of the public coaches on the day preceding Christmas.
The coach was crowded both inside and out, with passengers who, by their talk, seemed principally bound to the mansions of relations or friends to eat the Christmas dinner.
For the second source,
Le front froid qui traverse le pays d'est en ouest provoque un changement de temps et une baisse sensible des températures. En fin de semaine, l'anticyclone des Açores se déplacera vers l'Espagne, entraînant des perturbations orageuses sur la plupart des régions du sud-ouest.
we see that a mixture is obtained by summing these separated signals. Now, for the DOA estimation also, we have a script, and it's given in this one. It's the check recordings. Now, the algorithm also collect the recordings here for each block, and it's to say that this is, for example, there are moving sources inside the environment. Then by using this Python file, we will just create the trajectory for each block. Now we will try to see that how these sources are moving inside the environment. It's just putting the trajectories for each block. Now I open the trajectory. Now this is the center at the start. This is the microphone array location. Then we go through the trajectories. Now there are two separate sources. One is defined with X, the other one is O. We see that these are moving around the microphone array. Then since the audio block is changing, they are also changing in time. Inside this code, there's a tracker that tracks the sound sources and also separates the sound sources according to the current location. Now I think it's finished.